Okay, hello everybody. I am back outside with noisy traffic going by for this video. Professor Flynn, my esteemed colleague, complained that I was in the car too much for my recent video. So here I am on a picnic bench in the beautiful fall weather of Calgary on October 14th, 2021. It's actually 22nd. I was going to say your next homework is due in a week. It's actually due in a week and a day, Friday, October 22nd. And I just wanted to make this video to walk you through the basics of what to do for it, just to give you the maximum amount of time to process all the information. So what this is going to be basically an example of how to do power analysis. It's going to be done in kind of a funky way. So this is the first homework where we really aren't doing like linguistic-y data, processing linguistic-y data per se. We're just going to process some weather data. I guess we've done that before, but here it is. This is the database that I've shown you before, where we see all the that is a noisy car, where we see the temperatures, the weather data for Calgary and Toronto up to the year 2011. And basically we're going to try to answer the question, are the average July high temperatures in Calgary warmer or colder than those in Toronto? And I kind of addressed this already in one or two of the different lectures that I've posted so far. It's interesting because Karis the other day had a question about the temperatures in January, where we see a lot of variation in the Calgary high temperatures, not so much in Toronto, and just inferred from that Calgary's weather has to be different from Toronto's in July or January, of course, but that doesn't necessarily mean that the high temperatures are going to be different from each other, or at least the means of those high temperatures. So that's kind of the focus here, is the average July high temperatures in both of these cities. And as I mentioned here, this is looking at the data from when Calgary started collecting weather data in 1881 up until 2011. So it's basically inclusive of all that data for those 130 years. So we could answer this question like definitively. We have sort of the population up to that point. But let's pretend like we're running this like a regular experiment, in which we're first going to collect some pilot data, and then we're going to determine on the basis of those pilot results just how many subjects to run in the actual experiment. And this is the part which can get a little bit confusing. So I want to make sure it's clear here. So the analogy is that each month of July is a subject in the experiment. And then each subject will give 31 responses each, so-called, which is one high temperature for each day. So just use your imagination. From those 31 daily highs, we can calculate a mean high and a standard deviation for each subject. So if I'm talking about like the weather in July 1986 or something like that, you can calculate the mean high for that month in either city, and then also the standard deviation of those highs. And what we want to determine is whether the mean highs given by one set of subjects, Calgary or Toronto, are significantly different from the mean highs for the other set of subjects. Okay? And here's how we're going to work through this problem. So what I want you to start off with is to grab the high temperature data for Calgary and Toronto from the month of July in some random year. And if you have a preference for some random year that you like in life, go ahead and grab it. I guess since the data goes up to 2010, 2010, I think, because I didn't get all the way through 2011 here. But if there's some year in that span that you really like, you can pick it. Otherwise, you can randomly pick a year using this command in R, and I'll show you how that works here. It's just the sample command that we've seen before, and I'm going to basically sample any one number within the span from 1938 to 2010. And again, I'm picking 1938 because that's when my Toronto data starts. And then we're ending in 2010 because that's the last year in the database that's complete. And then I'm going to spit that one random year from within that range to the variable rando. So if I do that, then I get, turn off caps lock, Grandpa. Then I get 1981. It's a fine year, I'm sure. You can do that as well without the sort of spitting it into the variable if you want to, just by using the sample command. And then it's like you're kind of rolling dice here, which number you're going to choose. There's 1981 again. Imagine that. Told you it was a good year. Anyways, the idea here is that this is analogous to running a pilot study with just one subject in each group. So this is sort of like what you might do for like your honors thesis or something like that. Just to get rolling, you might just grab 2 friends from Verbatim or what have you, or maybe 2 of your grad student friends if you're in grad school, and say, can you just like pilot this study for me so I can see that it works? And then you get some basic data and you get a sense of like, you know, what difference the variables that you're testing actually make on the response data. But we're just going to do it with one random year in history. And I'm going to point out as well, as long as we talked about that sampling command, in case you're curious, in case you ever need to do this for whatever other reason, you can sample more than 1 year at a time from the same span. So this, adding this or changing this parameter to 17 from 1 will give you 17 different numbers within that grouping. And just looking at it closely, I don't think that's with replacement, so you could get the same number more than once in here, I believe, but that didn't seem to happen. But anyways, that's one way to do that. And I'm not going to say anything further about the sampling part of it, but just grab 1 year, either intentionally or randomly, whatever, just something to get started with. And then what you need to do to run that power analysis, and I'll go back over here to the notes that I posted. This is the power analysis lecture, and it's, sorry, it wound up being lengthier than I wanted it to be. I know it's like 2 hours of lecture online. Yeah, so I really should have split it up into 2, and kind of the most crucial part once we get through the conceptual stuff is how to actually calculate or answer questions like I'm talking about in this exercise, and the main question is like, how many subjects should I run in my experiment? So that, for the most part, is the relevant information for that is down here at the end of that lecture from about slide 35 on. I'm not going to dwell on that in detail in here, but in case you get lost or confused about what happens next in the homework, that's the first place I'd recommend that you look to try to answer your questions. And there's a little bit before that about effect sizes up here, so you might want to read that or listen to that as well. But what I want you to do is calculate an effect size for the difference between the average high temperatures for those 2 cities from that 1 month set of pilot data, right? So if your year is 1981, you're looking at the average high temperatures for Calgary and Toronto and seeing what the difference is. Also provide a reasonable estimate of the standard deviation for that set of pilot data. Then plug basically the relevant numbers you've calculated, the difference between the average highs and the estimate of the standard deviation, and then also the alpha and beta criteria into a power analysis to determine how many different subjects, i.e. years of data, you need to compare between the 2 cities in order to get a significant result, if there is a significant difference between the 2 cities. So you're going to start out with this one random year, and then like run this pilot analysis, and then it'll give you a number, say like maybe 25, and then you'd have to run collect the data from 25 different years for each city, and then put those results into a t-test analysis, which is what we're going to get to at the end of this. So remember, this is the command to calculate the power of the t-test right here. And the way it's set up here is that you have specified numbers for delta and standard deviation, and then you have your significance level, which is alpha, and your power level, which is beta. Well, it's actually 1 minus beta, but I'm just trying to keep it relatively simple here. And you can tweak those alpha and beta numbers as you see fit, and then the x and y numbers here, the difference between the means and the standard deviation, you have to get from your data. You can tweak these alpha and beta numbers, but if you do, just make sure you're not deviating wildly from their conventional settings. So, don't use, we have alpha normally as 0.05, but don't change it to like 0.5 or something ridiculous like that, because that wouldn't really be a meaningful test at all. So, within reason, you can do that, but normally I would just expect you to use the conventional settings just to sort of learn how to do this analysis. And this command is going to spit out a series of parameters, but the one you care about is the value of n, which is the number of subjects or years you need to run in your study. So we're thinking about this in terms of like, we ran the 2 guys from 1981, now let's go and collect the people from 1956 and 1967 and so on and so forth and get them to do the same study. We already know what sort of data they're going to provide because that's in the database, but still, that's kind of the analogy, as it were. Right, what I want you to do is this power test, just a regular power.t-test command, and then also run the power test with the paired option. which only differs with this parameter down here at the end, type equals paired. And we know we can pair up this data, right? Because it's like two cities, same year, same days, and the only thing that's different between the two data sets is the city that they're collected in, right? So the first set of questions you answer is question set number 1. How do the results of the two power analyses differ? How many subjects does each test tell you have to run? And then which type of test is more powerful, i.e. requires you to run less subjects? So it's kind of asking the same question 3 ways here, but it's just to make sure you get all the relevant data into your answer. If you answer these 3 questions, you should be fine. And you should be able to find all that out just from the results of these power test commands. Part 4, use the more powerful t-test to determine whether there is a significant difference between the mean July highs for the two cities. And so we kind of have to do this a little bit differently from the pilot. So for this t-test, what you need to do is look at the average high temperatures for the two cities from at least the number of years specified by the power analysis for that test. So let's say I've got an example here where the power analysis says you got to grab 3 different years. But maybe you'll have 20 different years, or maybe you'll have 12 or whatever. But what you're going to do is, if the number of years is n, then you select the July highs, the mean of the July highs from at least n different years from the database for each city and compare their mean temperatures. Actually, maybe I'll keep it the way it was. Then select the July highs from at least, compare their mean temperatures to each other in the relevant t-test. So this is the part where it gets confusing for students, and I just wanted to make sure it didn't get confusing for you, and I think I may have confused myself. But let's say we have 3 different years here that we're supposed to run based on our power analysis, and who knows what they might be, 1981, 1967, 1938. And so what you do is for 1938, you go and you calculate the average July high for Calgary and the average July high for Toronto. So you're just winding up with one number for each city for that year. You're not winding up with 31 different numbers for each city for that year. You average those highs and just put that average high into that slot in your test. And then you go on to whatever I said before, 1967, and calculate the average high for each city for that year. And then 1981, calculate the average July high for each city for that year, so on and so forth. And then you can plop these into vectors like this if you want. There's other ways to do that too if you'd like, but you're basically going to run a t-test comparing this data. And this is not real data for what it's worth. 1, we're not going to test that year. We're not going to test year number 2 either. And 5 is not a realistic average Calgary July high, even though some years it feels like it. There's going to be different numbers from this, right? But what you can do is say, actually, maybe I'll just do that. We'll put this set of numbers in the Calgary highs, and we'll put this set of numbers in the Toronto highs. And at the end of the day, so these are the average highs for the month of July in 3 different years for Toronto, and so on and so forth. And then you can just, not do exactly this, but basically this, run a t-test. Are they different? Well, this says it is, but that doesn't mean anything because it's just made up data, right? But that's what you're looking for, right? Is this information here when you run your t-test. So that is what will give you the answers to question set number 2. What are the results of this t-test? Did you get a significant effect? If so, which city has the higher high temperatures in July? Okay, so that's basically it. And like I said, hopefully I haven't confused you all completely with both the homework and the video. And if you are confused, please ask if there's any questions whatsoever, because I don't mean that part of it to be too confusing. And also, I don't mean this to be too laborious, right? So this is the grunt work way to do this part. And with like 3 numbers, it's not that bad to create vectors like that. Once you start to get more than 3, it can be problematic. So I will say that if your pilot study yields a really small effect size and your power analysis tells you that you need to run a very large number of subjects, like 50 or more, or maybe even 40 or more or so, you're welcome to run the pilot again with a different set of data. So some of you might just wind up with a power analysis that says run 3. Some of you might run with a power analysis that says 12, and some of you might get like 67. So I don't want the people who just randomly got 67 to have to do way more work than everybody else. So if it's a really large number like that, then run the pilot again with a different set of data. If it's, something borderline, like, at least, yeah, let's say 50 is the borderline for that. But if you get like 45, you can always ask me if you think that's too many or whatnot. And I will let you know as soon as I can. But basically, I don't want you to have to do too much grunt work for this. I just want you to understand the process. That's the main goal. And then, as usual, send me a write-up of everything you've learned, answering the questions, and what these tests mean, at least in your understanding. And then for this one, I need you to send me your saved R command consoles. Send me a write-up of your answers along with your saved R command consoles and workspaces via the Dropbox on D2L. So I can't recreate your random sampling without those workspaces, so please save those too and send them to me as well so that I can recreate anything that might have gone wrong in case something goes wrong as you're working through this. And that's it. Like I said, hopefully that all makes sense, and it's due on Friday of next week. And of course, I'll be available for questions as usual. And I can't wait to find out what the answer to this question is, because we all know how much I like the weather. All right, so that's it for now. I'll see you next time for homework number 7.